welcome back to 6.6, the last lesson of Unit 6. We are now going to be looking at the applications of rational equations or problems. You actually got a taste of it in the earlier lesson where you need to simplify the expression for, I can't quite remember, it was distance, time, and speed question. We will be looking at that kind of question again today, but we'll also look at some other kinds, okay? But before we start, again, here are two rational equations that you can solve. I'll let you try those two first, and I'll show you the answer in a bit. Okay, so here are the answers. Recall, when you solve rational equations, you need to multiply by the lowest common denominator to every single term, okay? Every single term needs to be multiplied by the common multiple, the lowest common multiple. So then these are the results, okay? Hopefully that's what you got as well. Make sure you check for the restriction. Sometimes you do end up with extraneous roots, okay? So make sure you check with the restriction. Okay, so that's what we did in a previous lesson, okay? So now we are actually going to look at some more problems. The first one, again, this is the distance, time, and speed question. Recall, the one I always use is the speed. Speed is distance divided by time. Again, I remember this because speed, a unit for speed would be like kilometers per hour. So kilometer is distance, time is, well, hour is time, right? So there we go. S speed is equal to distance divided by time. Okay, now we can manipulate the equation from here to what the question is asking, okay? So here it says, a boat travels at an average speed of 15 kilometers per hour in still water. The boat travels 12 kilometers downstream in the same time, okay, so that's key, same time as it travels 8 kilometers upstream, okay? Determine the average speed of the current. Okay, so here is the question. We're looking for the average speed of the current. So right away, I'm going to say let x be the average speed of current. Okay, so when you travel with a boat, when you go upstream, you are going slower for sure because you're going against the current. And if you're going down the stream, you're actually going faster because you're going with the current. Okay, so here is the speed of the boat in still water. So this is if there was no current, but there is current going up. Going down the stream, you're going with its current. In that case, the speed will be faster. So the speed going downstream, okay, would be x plus 15. X plus 15 is the speed going downstream. And if you're going upstream, it would be then actually, I'm going to write 15 plus x because this is the speed of the boat in still water plus the current, and it would be 15 minus x for the speed going upstream. Okay, so because the water is pushing against you, right? So you're slowing down. Okay, so now here's the key. It says it's the same time. Okay, so that means the time going up is equal to the time going down. So what we need to do right now is to come up with the expression for time going up. So what we need to do is we take this, okay, s equals to d over t, and we're solving for t. Okay, you can multiply both sides by t. You get st is equal to d. I'm going to do this in red actually. Okay, so I'm just going to erase this. So you get st is equal to d. If you're solving for t, you divide both sides by s. So t is equal to d over s. And that's what I'm going to do. That's what I'm going to use to solve this problem. Okay, so the time going up would equal to, this is up. Yeah, I'll write it here. T up. The time going up is distance. Well, the distance going upstream is 8. And the speed going upstream, we just did it here. The speed going upstream is 15 minus x. The time going down the stream is the distance, which is 12 kilometers, divided by the speed, which is 15 plus x. Okay, so now we have these two expressions, and we know that the time equal to each other. So here is our equation. 8 over 15 minus x is equal to 12 over 15 plus x. So here's the equation, rational equation, and then we can solve this. This one is not, okay, you know what, I'm just going to do it this way. Okay, so we can multiply by the common denominator, that's 15 minus x, and 15 plus x. So in this case, you get 8 times 15 plus x is equal to 12 times 15 minus x. Okay, now you can expand, that's 120 plus 8x equals to 180 minus 12x. You move the x's to the left, you move the numbers to the right, divide both sides by 20, you get x is 3 kilometers per hour. So what that means is the speed of the current is 3 kilometers per hour. So you would be going, the speed going up would be 12 because 15 minus 3 is 12, and the speed going down the stream would be 18 because 15, that's the speed of the boat in still water, plus the 3 kilometers per hour for the current. Okay, so but we are not looking for those two, we're just looking for the average speed of the current, which is 3 kilometers per hour. Okay, so that's how you do the first one here. Okay, now for the second one, I'll let you think about it and I'll explain in a bit, okay? Okay, so this is also a very typical question. This is about work. Okay, it's about the speed. This actually is similar to number one if you think about it. This is also about the speed and time, but instead of distance is the work. Okay, so here it says Raphael can paint a garage door in 3 hours. When Raphael and Roger work together, they can paint the same garage door in 1 hour. How long would it take Roger to paint the garage door on his own? Okay, so I am gonna, so again, here's the question. So I'm gonna say let t be the time it takes Roger to paint the garage door. Okay, so that's our variable. That's the question, right? So that's the variable. Okay, so now, like I said, this is actually quite similar to the first question. So we actually already solved it. I mean, we solved for t, okay? Here it says t is equal to distance divided by speed. That's the time. So it's actually very similar. What you think here is time is equal to, instead of distance, okay, so time is equal to, instead of distance is the work, the amount of work divided by speed. Okay, in this case, our work is 1 garage door. Okay, so the time it takes to complete the painting would be the number of garage doors divided by how fast, right? Divided by the speed. So the time for Raphael is gonna be, well, it says he can paint the garage door in 3 hours. So his time, oh sorry, oh shoot. Okay, so in that case, okay, so we need to solve for s instead. Actually, sorry, my bad. We need to solve for s. Okay, so I'm gonna rewrite this. This is what was this? Wait a minute. If I'm solving for s, I already have it, right? S is equal to, instead of distance, it's the work divided by time. Okay, the amount. So that would be like, the speed would be like 1 garage door per 3 hours. That's exactly the speed for Raphael, okay? Well, I guess both are R's. Okay, so speed for Rafa is equal to 1 garage door in 3 hours. Now, the speed for Roger would then be, well, 1 door in t hours. We don't know how long it takes, right? But that's okay. That would be the expression, 1 door in t hours. Now, the speed together, right? It says if they were to work together, they can actually finish this in 1 hour. So, the speed together is simply the speed of Rafa plus speed of Roger. Okay, so then here is the, again, here are the expressions, and this is how they are related. The speed actually adds up, okay? So the speed together is 1 door in 1 hour, and this is 1 door in 3 hours for Rafa, plus the 1 hour one door in t hours for Roger. So there is our rational equation, and we can solve this. Again, we got three fractions. We can solve this by multiplying everything by the lowest common denominator, which is 3t. You should get 3t is equal to t plus 3. We can then solve for t by moving t over to the left. 2t is equal to 3. Divide both sides by 2. You get 3 out of 2. So it actually takes Roger 1 hour and 30 minutes to complete painting the door on his own. Okay, so it's actually similar. These two questions are similar actually. So you can use this relationship, okay, to solve any of these work problems. Okay, speed is equal to the amount of work. I shouldn't say work. I should say amount of work divided by time. Okay, so the speed for Rafa would be 1 door per 3 hours. So that's his speed. For Roger, it would be 1 door in t hours, because we don't know how long it takes. Together, if they work together, it's 1 door in 1 hour. So their speed added together, Rafa and Roger, their speed added together would be 1 out of 1. Okay, so that's number 2. Number 3, it says how much lemon juice must be added to 2 liters of water to make lemonade solution that contains 20% lemon juice. Okay, so this we are talking about a pure lemon juice. We are adding some pure lemon juice into 2 liters of water to make lemonade that contains 20% lemon juice. Okay, so this is some pure lemon plus water. Okay, so, and I mean that's why it's lemonade, right? Not lemon juice. Okay, so again, here's the question: how much lemon juice? Okay, so let x be the amount. You should always write down your let statement. Okay, let x be the amount of lemon juice added. Okay, so then to figure out this concentration, we want 20%. So I mean, this is just the amount of lemon juice divided by the total volume, right? So part divided by total is actually equal to 20%, which if we write it as a decimal is 0.2. Okay, so again, part divided by total is 20%. Okay, 0.2. So the part that we're adding is x. Right, so we're adding x. This is the part, because all of these x's, or all of those x, or all of that x is just lemon juice. Total would be some lemon juice plus some water, right? That's the total. This is the amount of lemon juice in that lemonade, and this is the total volume, right? And this is equal to, well, it says 20% lemon juice, so this is equal to 0.2. Now, I'm gonna rewrite, or instead of writing 0.2, I'm gonna write this as 2 out of 10, okay, just as a fraction, or you can write as 1 over 5. Now, once we get this, we can then solve this again by multiplying by the common denominator, which is 10 times x plus 2. Okay, so then we get x times 10 is equal to 2 times x plus 2. Notice how you are just cross multiplying, right? I mean, this technically is why cross multiplying works. If you only have one single fraction on each side, I mean, that's the result, right? Cross multiplication. Anyways, this is just on the side. Cross multiplication in math actually does not exist. This is actually what's happening here. Anyways, so you can solve this equation now. 10x is equal to 2x plus 4. You can solve for x by moving x's to the left. You got 8x equals to 4 divided by 8. You get x is 4 out of 8, or 0.5 liters. So if you add 0.5 liters of lemon juice into 2 liters of water, you actually get 20% lemonade. Okay, 20% lemon juice, or a lemonade with 20% lemon juice in there. Okay, all right. Number 4, I'm going to ask you to try it, and I will show you in a bit, because this is again the distance, speed, and time question. However, this one is a little tricky here. Okay, a little tricky. It says, okay, so I'll let you try first. Okay, so if you read the question, it says a car travels from home to work at an average speed of 60 kilometers per hour, and because of traffic returns from work at an average speed of 40 kilometers per hour. What is the average speed for the entire trip? So you might be thinking, okay, well, if the way going to work is 60 and the speed coming back is 40, so the average would just be 50 then, right? I mean, that's midpoint, right? 50 kilometers per hour, it's easy. Unfortunately, it does not work that way, okay? That's not what it is. And it is because when the speed is slower, it actually takes longer to get there. So the weight of this speed is actually more than 60, okay? Because it does spend more time. So you actually need to put more weight into this speed here. Okay, so the way to do this question is like this. So you need to know average speed. First of all, average speed is equal to total distance divided by total time. Okay, it's the total distance divided by the total amount of time. Okay, so that's what you need to do. Now, we don't know the distance. In fact, it doesn't really matter actually. So what I'm going to say is, because we don't know the distance, I'm just going to say each way the distance is x. Okay, therefore the total distance is going to be 2x. Okay, so I'm going to say right here, let x be the distance from home to work. Okay, so one-way distance. So total will be 2x. Now the time in total, recall from the previous equation, time is simply equal to distance divided by speed, okay? Now the distance going to work is x, and the speed going to work is 60 kilometers per hour, and plus the time coming home, right? So the distance remains the same, that's still x, but the speed going home is now just 40. So this is the actual expression for the average speed for the entire trip. We don't actually need to solve anything, we're just simplifying here actually. So this might not be a good example to put here because we're not actually solving, but you know what, it's fine. We can simplify this, not a problem, okay? So this is a fraction, so when you add fractions, recall you need a common denominator. This is 60 and 40, so the common denominator is 120. To go from 60 to 120 times 2, from 40 to go to 120 times by 3, so you get this, 3x. You can combine like terms, or sorry, you can add these two fractions, you get 5x over 120. Now from here, you can divide, right? Remember this means division, so you go 2x divided by 5x over 120. And when you divide fractions, remember you're multiplying by the reciprocal. Okay, and now we can simplify this. The x's, you see, the distance does not matter. X's actually cancels out. You can reduce this. You can divide this by 5. You can divide this by 5, you get 24. So at the end, the average speed is actually 48 kilometers per hour, which again makes sense because 40 does take on more weight. So the answer should lean towards 40 kilometers per hour, a little bit more than 60. Okay, so be careful. It's not 50, okay? That is a misconception, okay? Anyways, okay, number 5. So this one it definitely is a solving question, so I'll let you try it, okay? All right, let's see if you got it right, okay? So Ray and Ann ride a bicycle a distance of 4 kilometers each morning. They both finish at the same time, but Ann starts 1 minute before Ray, and Ray travels 1 kilometers per hour faster than Ann. At what speed are they traveling? Okay, so it's quite a bit of information here. So again, let's just state or write down our let statement first, okay? It says, the question is, at what speed are they traveling? So I'm going to say let x be, whose speed do I want it to be? Let me say x is Ann's speed. Okay, if x is Ann's speed, then, so therefore, Ray's speed is, well, it's 1 kilometers per hour faster, so it will be x plus 1. Right? If x is Ann's speed, then Ray's speed will be x plus 1 because he's going 1 kilometers per hour faster. Okay, now it says they both ride the bicycle a distance of 4 kilometers each morning. Okay, so the distance is the same, but because it's at different speed, therefore the time is going to be different. However, it says they finish at the same time, but and start 1 minute earlier. Okay, and start 1 minute earlier. So what I'm going to do is I'm going to write down the expression for time. This is Ant's speed. Ant's time, and her time is simply the distance divided by speed, so 4 divided by x. For Ray, it is simply 4 divided by x plus 1. Now, we need to somehow compare these two times, and it does tell us here, it says they finish at the same time, but n starts 1 minute before. Therefore, n actually takes 1 minute longer. Okay, let me say it again. N takes 1 minute longer than Ray, which means if we take that 1 minute away from n, the time would be the same. Okay, let me say it again. Because n starts 1 minute earlier, therefore n actually takes 1 minute longer. So if we take 1 minute away from n's time, the time for both n and Ray would be the same. Okay, so this is the basis on how I'm going to come up with this equation here. Let me say it again. This is n's time. If I take 1 minute away from n, this would actually equal to Ray's time, right? Because n actually takes 1 minute longer. So if I minus 1 minute from n, the time is now going to be the same. Okay? Hopefully that makes sense to you. Now, there's a problem with this equation, okay? Our speed is in kilometers per hour. However, this is 1 minute. Okay, you can't solve a question with different units. So what I'm going to do right now is I'm going to convert 1 minute into hours. And that's easy because I know 1 minute is simply 1/60th of an hour, because there's 60 minutes in an hour. So 1 minute would be 1 out of 60. And now this is my rational equation that you can solve. Okay, so now I'm going to solve this. Again, you multiply everything by the common denominator, which in this case is going to be the long one here, x times 60 times x plus 1. Okay, everything. Multiply everything by the common denominator here. So it means we need to multiply 4 by 60 and by x plus 1 minus 1 times x plus 1 equals 4 times x times 60. Okay, now we can expand this. You should get 240x plus 240 minus x squared minus x equals 240x. Okay, and now we need to solve this. Well, you can see the 240x, they just cancel out, right? Because you have 240x on both sides. Now I'm gonna solve for x squared. I'm gonna make it equal to 0. It already is equal to 0, but I don't like it when x squared is negative. So I'm just gonna make it positive by moving everything to the right. Well, I guess I didn't. I still made it on the left. It doesn't matter. Okay, so x squared plus x plus, minus 240 is 0. This is definitely is it factorable? It should be, or not. I thought it was. Okay, or did I make a mistake? I better check. I remember it was factorable. Okay, so let me see. 4 times 60 times x plus 1. Yeah. 1 times x plus 1, yes. 4 times x times 60, that's 240x. That's 240 minus x squared minus x. 12 and 10. Okay, it's definitely factorable. I just couldn't find the numbers. It was x plus 16 times x minus 15. 225 plus 15, 240. Yes, correct. So there we go. That means x is equal to negative 16 or 15. Now, obviously, x is the speed. The speed cannot be negative. Velocity could be negative, but speed cannot be negative. Therefore, Ant's speed is 15 kilometers per hour. And Ray's speed, because it's 1 kilometers per hour faster, so it's going to be 16 kilometers per hour. And there is the answer. Okay? So So this minus 1 out of 60 business could be confusing. Again, in the past, that's where students usually get in trouble with. So just think carefully who's going faster, and whoever is going slower, you need to take 1 minute away. Or you could add 1 minute to the one who is faster, right? Because he's going faster, therefore if you add 1 minute to his time, then their time will be the same. Okay, either or, it's gonna work. Okay, last example, number 6. It says the sum of a number and twice its reciprocal is 9/2. We are looking for the number, okay? So let x be the number. So the sum of a number, so sum, remember it's plus. So x plus the sum of a number and twice its reciprocal. Remember, reciprocal means 1/x. But twice, the reciprocal means 2 times 1/x. And this is 9/2. Okay, so the sum means plus of a number, that's x, and twice, so 2 times, its reciprocal, 1/x, is 9/2. Okay, now we can solve this. I'm going to multiply this first. 2 times 1/x is 2/x, and that's 9/2. Now we can multiply by the common denominator, and that is 2x. So 2x times x is 2x squared. This is 4 equals 9x. We have 2x squared minus 9x plus 4 equal to 0. This, I believe, is factorable as well. 2x and x minus 4 minus 1. Yep. So x is either 1/2 or positive 4. And both actually will work, I believe, okay, because they are not part of the restriction. The restriction here is x can equal to 0, and 1/2 and 4 are not 0, so we're okay. Okay, that's it. Yeah, hopefully this wasn't too difficult for you. You need to practice, okay? So these word problems, you just need to see many times and use your strategies many times, and once you get used to it, they are not that difficult. But if you don't have enough practice, they might be difficult for you to extract information, okay? All right, do some practice, and this is it for Unit 6. Good luck. Let me know if you need help.